We're going to be making the following laser system in UE 5.1. We'll be making the following actors, which is laser spawn, laser target, laser cube, and laser reflect. The laser cube will be in the next video, along with the laser reflect because it's more complex and would have taken too long to do in the first video. We're going to start off by making the main assets we will be needing throughout the tutorial first. So we're going to start with creating a blueprint interface. We're going to call it BPI_lasers. Next, we're going to create a parent actor called laser parent, and we're going to use it to create the following children. A_laser, A_laser spawn, and A_laser target. We're going to start with the parent class, so open that one up. First, we're going to get a static mesh component, which we'll be using in all the children to give them a visual. Next, we're going to make a few variables. The first variable will be a boolean that we will call active, which serves to check if an actor is creating a laser or being hit by one. Next, a linear color called laser color, which we'll use to change the laser color later on. Make sure it's exposed on spawn. A variable of type A_laser spawn, which we created earlier, called spawn reference. Make sure it's exposed on spawn as well. This variable will allow us to indirectly track the origins of each laser. And finally, a variable to track all the lasers attached to a specific actor, which we will call lasers attached, and it will be an array of type A_laser. We can close the parent actor as we won't need to make any changes to it for the rest of this video. Next, open the laser spawn, and we'll start by giving it a static mesh. For the tutorial we'll be using the basic cone, but feel free to use any static mesh you want, it has no importance. We're just going to move it slightly a bit up in the viewport so that it can be more easily attached to walls. Now add an arrow component, make sure it is rotated and in a position where it is not overlapping the static mesh and is pointing in the direction you want the laser to go. The variables unique to the spawn, we'll start with child lasers, which is an array of a laser type. Next is a string called ID, which will be crucial to the proper removal of lasers later. And to finish, create a variable called spawn laser. Editor's note, spawn laser is never used, so you don't need to create it. Now we're starting to get into the blueprints. We can start by removing event tick and event begin overlap, as we'll only be using event begin play. From begin play, we are going to drag off and set spawn reference to self, as we're currently setting up the spawn actor. We're going to perform the same logic for the ID as it is in the spawn. We want a unique ID, so we will be using getDisplayName. And finally, we're going to create our laser using spawn actor from class. We search for A_laser and select it. We split the transform. Now with our arrow components, we are going to get world location and plug it into the location. And for the rotation, we will simply get our actor rotation. We search for get laser color and get spawn reference and attach them to our spawn actor. To complete our begin play, we add our new laser to child laser array. Now we're going to work on the key actor of the whole system, that being the laser. So we're going to open it and set it up. Just like we did previously, we're going to give it a static mesh. In this case though, I suggest using the exact same one as me, that being the cylinder in the level prototyping directory. The reason for this is because the pivot point is at the bottom of the geometry, meaning it's easy to use and only needs to be scaled. We're going to create an empty function and place it after the begin play. It will later serve to change the color of the laser. But we're first going to focus on making the laser work. So we create a function called setEndPoint. We'll be calling this function in the event tick. This function will contain most of the logic for the system. We start it with a box trace by channel to determine the length of our laser. For the start location, we will be using getActorLocation and getActorUpVector to make sure that we don't collide at 0. We multiply the up vector to start the trace in front of the actor. We set a half size of 0.5 on all axes. And for the end location, we're going to multiply the up vector by a local float variable we will call lRange. We are using a variable because we will need it later. We then add the resulting multiplication to our start location, and don't forget to set the default value of lRange to something around 3000. From the box trace, we will save the out hit as a local variable called lHitInfo. Next, we will scale our laser based on the hit result. So we break our hit info and get distance. We add 1 to ensure the laser is slightly longer than the hit so that it really hits the target. Then we divide by 100 to convert the distance to a scale. We grab our static mesh component and set world scale 3D. We want to split the vector, set x and y to 0.05, which will make it a thin cylinder. And for z, which will be the laser length, we need to put a select. The reason for the select is because if the box trace hits nothing, it will return 0, so we need it to select our lRange in that case. So we use the blocking hit that we get from lHitInfo for the select, and we set distance to A and lRange to B after having divided by 100. Now we can compile and place our spawn actor inside the level to see if it is working. As you can see, it works as intended, the laser appears and goes to the next wall, but there are a few issues. First, the player collides with the laser, which we don't particularly want. Also, a laser, being a laser, shouldn't emit a shadow. To fix these, we open our laser again and select our static mesh. Scroll down to collision and change the preset to custom, and we select overlap in the collision response. We can also set visibility to ignore, as lasers will not be interacting with each other. Next, we want to disable the shadows, so we do a search for shadows in the details panel and set cast shadow to false. Let's run the game again, and now we can walk through the laser, no problems, and we don't see any shadows. But it doesn't look much like a laser, so let's fix that. Create a new material, we'll call m_laser. Open it. Once it's loaded, we hold 4 and press left click to create a 4 vector. Right click on it and convert to parameter. We'll call that parameter color, and we'll attach it to our base color. Next, hold S and press left click to create a scalar parameter for the intensity. Set its default value to 100. And finally, hold M and press left click to create a multiply node. Attach the color and intensity to the multiply and attach it to the emissive color. Apply and save the changes, and we have a complete laser material. Now back in our laser blueprints, select the static mesh and apply our newly created material. We forgot to set our default value to the color, so open the material again and set it to red. Next, we can change our color function we left blank earlier and put it to use. Get the laser color variable. Get the static mesh and search for create dynamic instance. Select our m_laser material for the source material in the node. Drag from the return type and search for set vector parameter value. Once you have that node, type in color inside the parameter name and attach the laser color to the value. We can now run the game, and the laser is not the correct color. Something went wrong. So we forgot to change the variable on the spawn, which determines the laser color. If we change it to red and run it again, it works as intended. Let's try with another color to ensure that it is working, and even if we put it as blue, we get a blue laser, so everything is functioning correctly. Currently, we have a laser that extends and is blocked by objects. The next thing we want to do is add a target. To do so, before going into our laser target, we're going to use the blueprint interface we created at the beginning. So we open the blueprint interface, and we're going to rename the function that we see to laser bounce. This function will have 3 inputs. The first is a reference to the laser hit, or more accurately, the laser that is hitting the target. Make sure to use the type A laser. Next is a boolean called hit response, which will check whether we are hitting an object or not. And finally, we want to get the hit information of type hit results. And we also need to add one output of type A laser, which we'll call new laser. It is the new laser that we will create once we hit an actor such as the cube or a reflective surface. We can now close the blueprint interface because we won't be using it anymore, As we just finished setting up the blueprint interface, we are now going to make use of it within a laser. Inside of the setEndPoint function, from the hit info, we want to save another local variable called lHitActor. We want to check if it can call our blueprint interface, so we'll drag from it and search does implement interface. Attach the return value of this function to a branch and on true we will be able to call our function laser bounce by right clicking and searching for it. Attach lHitActor to the target and set hit response to true, self to the laser hit, and lHitInfo to hit information. With this now in place, we can place our A laser target in the level and put the final touches in the blueprint of laser target. Inside laser target, we start as usual by setting up the static mesh. Now we want to set up the blueprint interface to be usable inside this actor. So to do that, we open the class settings and go to implemented interfaces and click add and search for our BPI lasers. Once you have done that, a new category should appear below functions called interfaces, and we will double click on laser bounce to open it. Once inside, we're simply going to add a print to see if our function is indeed being called. Let's just align our spawn and target and run the project. And it is indeed printing correctly. We should also check that it stops when we block the laser with an obstacle. And it does indeed stop printing once a cube is placed in front of the laser. To check this without using a print, let's create a function called puzzleSolved, which will change the color of the static mesh to the color of the laser that's hitting it. The function will need a single parameter of type linear color. We need to do the same as what we did for laser color, so we start by creating a dynamic material instance, but instead of using the material we created, we'll use something called m_solid as the source material. Drag from the return value and type set vector parameter value, and use base color as the parameter name. But unlike with laser, we want to use a select node with active to determine whether we use the parameter or simply remain gray. We now return to the laser bounce function and we set active based on our hit response parameter and replace the print string by puzzleSolved. We get our laser color from the parameter laser hit. Now let's run another test to see if everything is functioning as intended. As we can see, the target is blue like the laser. Let's see what happens when we block the laser now. It doesn't turn back to gray. The reason for this is in the laser we never call laser bounce with hit response false. So let's fix that by opening up a laser and setEndPoint. To solve this issue, we are going to need to create a new variable. Make sure it's not a local one. Call this variable lastHitActor and of type actor. First, we want to check whether local hit actor and last hit actor are different. If they are, we want to check whether the last hit actor could call our blueprint interface. We want to make a copy of what follows here, as we're going to be using it twice, once with hit response false and once with hit response true. On the branch equal true, we want to change our L hit actor with last hit actor, and we want to change hit response to false. If they are equal, we want to use what we copy to enable hit actor, if it can call our blueprint interface. To finish this function off, we need to set our last hit actor to our local hit actor. So to do that, we're going to add a sequence node right after the set world scale 3D. We use a validated get to ensure that we are not setting a null reference. Also, we need to remember to make sure that we don't forget to change local hit actor to the last hit actor on the if they're different branch, otherwise we'll not be disabling our previous actor but only disabling the new one. So now we can run the game one last time and push the cube in front of the laser, and our target does indeed get deactivated. Everything is functioning as intended. So that does it for the basics of the laser system. In the next video we'll be adding the reflection and a cube. Thank you for watching and making it all the way to the end. As this is my first time making a tutorial, please let me know if you enjoyed it, or if you didn't, let me know how I can improve for the next one. The second part will be the last, and it will be coming out in the next 2 days.